Here we're going to simplify and we're going to make the assumption that all the variables are positive. And what that means is that we're not going to have to worry about putting absolute value bars on the answer for our even index roots. If we know the variables are going to be non-negative, we know our answer is going to be positive anyway, so we don't have to slap the absolute value bars on it to make sure it's so. Part A is the cube root of y squared over the square root of y. We're going to use rational exponents to simplify this. This is the easiest way to do this when we have unmatching indices. So we're going to rewrite the numerator, third root of y squared, as y squared raised to the parenthesis 1/3 power. And we're going to rewrite the bottom, the square root of y, as y raised to the 1/2 power. Okay, now the exponents will multiply together in the numerator, so it's y to the 2nd power times the 1/3 power over y to the 1/2 power. Now go ahead and multiply the exponent in the top, 2 times 1/3, to get y to the 2/3 power over y to the 1/2 power. Now we have the same base y on the top and bottom, so we can write this as a single base y raised to the top exponent minus the bottom exponent. And we have a complication here because we have to subtract fractions and they don't have the same denominator. So let's figure out what the least common denominator is for these fractions. The LCD is equal to 6, so we want to write both of these fractions with a 6 denominator. So we'll change 2/3 to 4/6 minus 1/2 will be 3/6. All right, you see how we did that? We multiplied the top and the bottom by the same number in order to get the denominator. The first one we multiplied by 2/2, and the second one we multiplied by 3/3. Okay, so let's go ahead and do the subtraction. 4/6 minus 3/6 leaves 1/6, so we have y to the 1/6 power. And then finally, since the original question had radicals and not fractional exponents, we will respect the question and answer in the same form as the question. This is the 6th root of the base y. Part B, we're going to simplify the 3rd root of the square root of x to the 3rd. Okay, so we're going to do this by using rational exponents, which is the way to go. Believe me, it's the way to go. So the inner square root I'm going to rewrite as the 1/2 power. So we have the cube root of parenthesis base x cubed raised to the 1/2 power. Okay, now we're going to multiply the exponents together under the radical. We get the cube root of x to the 3 times 1/2 is 3/2. And now we're going to convert the 3rd root into the 1/3 power. So this is equal to the base x to the 2/3 power, parenthesis, raised to the 1/3 power. And that is equal to, multiply the exponents together, 3/2 times 1/3 simplifies to x to the 1/2 power. And since the question had radicals, we're going to answer in a radical. This is the square root of x. And finally, part C is the 4th root of 49 divided by the square root of 7. Now we're going to use rational exponents here since we have unmatched indices. This is base 49 raised to the 1/4 power on the top, and on the bottom it's base 7 raised to the 1/2 power. Now we would be able to use some rules of exponents if we had the same base on the top and bottom. And I know I can write base 49 in the form of 7 to some power. Oh yes, because 49 is 7 times 7. I can rewrite the top as, let's see, well here we're going to get the same base if possible. Just a little note to remind you what we're doing here. On the top, I'm going to write the 49 as 7 to the 2nd power in parentheses, and don't forget the 1/4 power on the outside. And the bottom is still 7 to the 1/2 power. Okay, so I can multiply the exponents together upstairs and get 7 to the 2 times 1/4 is 2/4 over the bottom, 7 to the 1/2. That simplifies as 7 to the 1/2 over 7 to the 1/2, which is equal to single base 7 raised to the top exponent minus the bottom exponent. I'm able to do that because I had the same base on the top and bottom. So 1/2 minus 1/2 is 0. 7 to the 0 power. Well, 7 to the 0 power is equal 1. But you know, you could have cheated in a way. You could have gone back here where it was 7 to the 1/2 over 7 to the 1/2. And you could have canceled the factor on the top that matched the factor on the bottom, and your answer would have been the same solution you got at the end of this problem, number 1. So we could have stopped early and done it that way.